In the previous section, we discussed the fact that the standard normal distribution was made up of values that we call z-scores. The technical definition of a z-score is the number of standard deviations that a data value falls above if it's positive or below the mean if it's negative. So now when we choose to look at normal distributions that are not standard, meaning their mean is not 0 and their standard deviation is not 1, we will need to take that value and standardize it before we can use our standard normal distribution. The formula for standardizing a value of x is to subtract the mean and divide by the standard deviation. And that's the formula that you're seeing right here. So in our example, we have a normal distribution. You see the graph here to the right. It has a mean of 64 and a standard deviation of 3. All right, the value that we're looking at here is a height of 67 inches. All right, so if I want to standardize this, I'm going to take the value 67. I'm going to subtract its mean, 64. And I'm going to divide by its standard deviation, which is 3. All right, so calculating my value here, I get a z-score of 1. And that tells me that this value, a height of 67 inches, is 1 standard deviation above the mean. And what happens is when we want to look at a probability, which you're going to see in the next video, we can take a z-score, like 1, to our standard normal table, and the area that corresponds to that z-score is the same thing as the area that corresponds to the value of x. All right, so in this next example, all we want to do is find the z-score for a value of 28. So information given, the time it takes for a compact fluorescent bulb to reach full brightness is normally distributed with a mean of 29.8 seconds and a standard deviation of 4.5. Now again, the value that we want to look at is a time of 28 seconds. So if we're going to standardize that, we would take that value, 28 seconds, we would subtract its mean, 29.8, and we would divide by the standard deviation, which is 4.5. Now, if you need to round your z-scores, we usually round them to 2 decimal places so that we can look them up in the table. This one does not need to be rounded as it comes out to exactly negative 0.4. All right, and if I want to interpret that, what this is telling me is a value of 28 is 0.4 standard deviations below the mean. All right, and the reason it's below is because I get a z-score that is negative. All right, so what you're going to be doing from here is when you are given data sets where the mean is not 0 and the standard deviation is not 1, like what you see here, you'll just need to standardize that value before you can take it to your standard normal table and find the corresponding area under the curve.